Hello class, let's start lecture 30. We will talk about linear regression. I'm your instructor, Miss Laura Low. We are in lecture 30. In module 11, we talk about correlation. And the previous lecture, we talked about the correlation coefficient. So today, we will continue to talk about linear regression. We are predicting one numerical variable from another, and we will explain the regression line. Then the last lecture in week 11, we will talk about the least squared. So the first thing, let's review correlation coefficient. In the previous lecture, we talked about correlation. The most important thing, we introduced correlation coefficient that we represent by R. So the correlation coefficient R is measures linear association. So pay attention, we only talk about the association, we focus on the linear association. So according to the value of R, they are between -1 and 1. In order to calculate the correlation coefficient R, you need to convert both variable. We focus on two numerical variable. So the both numerical variable, they need to convert to the standard unit. So if you remember, standard unit is, we have the average is 0. Then we have the 1 is the standard deviation. To convert standard unit, we will have the each value minus the average for that variable, then divide by standard deviation. So the R always equal to, always within -1 and 1. So you can see here, according to different R value, if R really close or equal to 1, R equal to 1, that means, see here is R equal to 0.99. So all the dots very close to the straight line. So if R equal to 1, that means all the scatter is perfectly straight line and the slope is going up. If R equal to 1, all the scatter is perfectly in the straight line and the slope is positive. On the other hand, if the R equal to -1, scatter is also in a perfect straight line. Just one thing, the slope will be negative. So if you have the R equal to 0, they don't have any linear association. The technical term, we say they are uncorrelated. So then you can see the example like here. So you can see if R equal to 0, they are not really forming one line. Because you can see they have some dot on this line, some dot on this line. So that's why they don't really have any specific line can perfectly describe all the dots. So then when you have your R become bigger, so then you see 0.2. So they kind of center a little bit for the scatter, but still not very easy to see the straight line. Then equal to 0.5. Kind of, yeah, they are close to a straight line here. Of course, when you are equal to 0.8, that we can see more clear, they will have a straight line describe those scatter. On the other hand, the same thing, R equal to 1, those scatter will be a perfect line. So if your correlation coefficient is negative, they kind of, like we say, they are negative they have negative association. So the focus on the data will be on the top left and right bottom. Again, the reason R will be between -1 and 1 is the definition for the correlation coefficient, how we calculate the R. The definition for the correlation coefficient is the average of the product of the two numeric variable in standard unit. So that's why you have all the product of x, y, then we add together, then find the average. So that's also have our standard deviation and the average characteristic to make our R is within -1 and 1. At the end of last lecture, we show you some example about the correlation coefficient. Then we see the hybrid car. So then we try to find the MSRP relationship with the gas mileage. So here we will continue to show you. We will see the value in different association, how the shape and the R value will look like. So then we will see how we will interpret our correlation coefficient. So again, let's see here. That's we talk about all the correlation coefficient. Before we calculate R, we need to have the both exits to have the numeric variable convert to the standard unit. And after you convert to the standard unit, you can plug into this function correlation. We pass the table and two numeric variable we want to find their correlation. So then you can have the correlation using the average of the product of the two variable in standard deviation, in standard unit. So then we got the correlation value. So again, let's continue to see our example last lecture. We have the hybrid car information. So remember in the hybrid car information, then we find out the acceleration for the car and MSRP. They kind of have the positive association. So then you can see they kind of, right, we can have one straight line to represent that. So here, of course, we can plug into our function to get the correlation value on correlation coefficient R between acceleration and MSRP. But here, even we don't have the value yet, can you guess what is the R value will be? Right. One thing is we know they will be positive. So since they are not really very clear straight line, so maybe around 0.5, then we can guess. So then we can see, oh, that's even better. Yeah, they are almost like 0.7. Okay, so that you can plug your scatter plot. So then get the two numeric variable you are interested for to see from the scatter to kind of know their association. So then we can calculate correlations. So we talk about the correlation coefficient is between the two numeric variable. So then let's guess. So now if I count, so here we have the acceleration is the x-axis. MSRP is the y-axis. So if we reverse the xy axis, how the scatter will look like. Yeah, pause the video, then think about that before we see the answer. Yeah, so that's here, right? So let's convert that's the scatter plot. Then again, also we try to find the correlation. Yeah, before we see the answer, yeah, you just guess what it will be, and the correlation will be different or not. Yeah, so then what you see here, if we just have our xy axis to make them reverse each other. So then you can see here. Okay, let me make that a little smaller. Okay, so you can see here. Since we just reverse the xy axis, it just kind of like you reflect. So here is x equal to y line. So then you kind of just they are symmetrically to the x equal to y. You see here we have more dots, but then they become here. Okay, so that's if you reverse your xy axis and to plot the scatter plot. But on the other hand, if we switch the xy axis, the numeric variable, how about the correlation value? Yeah, so then if you continue to find the correlation value, okay, so earlier we have almost 0.7, right? So even we reverse that the xy axis, your correlation was still the same. Right, because here you just reverse their axis, right? So when they convert to the standard unit, they are still the same. Then the correlation coefficient definition is the average of the product of the xy in standard units. So that's why their correlation is still the same thing. Okay, so that's the example we see from last lecture. But let's see more example about the correlation. For example, now here, let's plot a scatter plot. So this one actually you can see we have the x value. So then actually y is the square of the x value. So that's why you can see they are perfectly, you give me the x value, I can tell you what is the y value. So what do you think about the xy association? What their relationship? They should be highly associated, right? Because one thing is, give me the x. I can give you what the y is. Just they have the x equal to 2, y equal to 4. X equal to -2, y also equal to 4. So in this nonlinear association, what is their correlation? Okay, so surprisingly, yeah, the correlation is 0. Even we see they are perfectly associated to each other. Okay, however, like earlier we say, the correlation coefficient is measured the linear association only. So that's why even in our example, y equal to x squared, so this, they have strong association, but they are not linear association, linear relationship. So that's why their correlation is 0. Okay, so that's the nonlinear relationship. So the other one that I see, we have another scatter plot we draw is, actually this one is x equal to, y equal to x. Because you have the array x equal to 1, 2, 3, 4. So then actually y equal to 1, 2, 3, 4. So this one, did you see what? Yeah, they form a perfect straight line, right? So then since the slope is positive, right, so if you try to find the correlation, they will equal to 1. Yeah, so that's, you have 4 dots in the scatter plot. They are perfectly form a straight line. But sometimes we do have outlier, right? So in the continued example, we say that's outlier. Why they are outlier? Because we have 4 dots. They perfectly form one straight line. But we do have another data. They are totally outside and far from this straight line. Yeah, so you still can try to calculate to find the correlation. Then we find out the correlation is equal to 0. Yeah, because this outlier. Because the correlation coefficient is the average of the product of x, y in standard unit. So we say that's the outlier. A lot of time in data science, we try to remove the outlier. However, when we remove the outlier, we need to make sure this outlier, for example, this one, maybe that's a typo, or that's a human error, then we can remove that. Or sometimes they have some mistake happen on this outlier. That's why we need to remove the outlier. But sometimes if this outlier is really real, exists. For example, in Bay Area, especially in Bay Area, most of the time we have the sunny day. But once in a while, of course, in summer, we all have the sunny day. But then, I remember So then, but sometimes in winter time, maybe, you have one day it's raining. We cannot say because we have 60 days, almost 2 months straight sunny day, then you have one cloudy day or raining day, we need to remove that. Because this raining day is really exist. So something like this kind of outlier, we should not ignore that. On the other hand, we should try to explain about this outlier. Okay, so here, back to our care in interpretation. Okay, So we need to watch out is when we have the scatter plot, we need to make sure our conclusion. So then about the causation, make sure you don't have the false conclusion about causation. And also when we talk about the R correlation coefficient, we are focused on only the linear relationship. So when you have the non-linear association, their correlation coefficient R equal to 0. Same as sometimes you have the outlier. Okay, so then in the next video, we will continue to show you one example, the real world example in the XAT. But here on this video, we will stop here.